we continue to look at complex numbers. What you want to do right now is see how you represent complex numbers on a number line. Looking at representation on the number line. Now you remember when you talk about a number line, you're looking at a horizontal line, right? And in the middle of that horizontal line you have your 0. Then you have your numbers 1, 2, 3, 4, and so on and so forth, going positive numbers to the right. You have -1, -2, -3, -4, and so on. Negative numbers going to the left, alright? Let me just continue. 5, 6, 7, 8, 9, 10, negative. It should be -5, not -6, -5, -6, -7, -8. And it goes on and on like that. But these are real numbers. It's called a real number line. Now, here. In order to represent complex numbers, then mathematicians use what is a vertical axis here now to represent, well, first of all, the horizontal axis represents the real part of the number line. Then the vertical axis represents the imaginary part. So this is called the real axis, and this now is the imaginary axis. You have your 1, 2, 3, 4, 5. In the case the I-axis, let's put I. -1, -2, -3, -4, -5, and so on. Alright? Here now, when I have these leaning to the left, let me rewrite them. -3, -4, -5, and so on and so forth. Now, generally, when you have a pair of an axis like this, right, and you want to represent, say, A plus JB, not J, IB. You look at where A is located on the horizontal axis, that's the real axis. Then you look on the imaginary axis to see where B is located. Then you, if it's on a graph paper, you can see it directly. If it's on a plain paper, you estimate where it is or do a measurement, and then you say, you draw a line from here. It's just like what you would do with vectors. Alright? So, here now, this is the line A plus JB. Now, I've drawn a line from the origin to AB because the complex numbers will start from the origin. Now I've seen diagrams where they don't use a line, they just use a dot, right? And if this was our A and this was our B, you just use the dot, and our A plus JB would look like that. But even when you have the line, you don't put an arrow on the line. What you do is put a dot here. So this is the complex number a plus jb. Alright? Now, going back up to our graph. Suppose, for example, we want to represent this complex number 1 plus j, not j, I keep saying j, plus ib. In engineering, you sometimes, in electrical engineering, sometimes use j. But let's stick to I for now, right? If you specialize in electrical engineering, you may find yourself using j because you don't want to confuse I with I, meaning the intensity of electric current. Alright? So this is A plus IB, but in this case, our I is 3. We put the 3 in front of the I. A plus 3I. Right? So we want to represent that on the number line. In this case, our number line turns out to be a graph with x and y axis, where x axis is our real axis and the y axis is our imaginary axis. Now in this case, what we do is locate from 0, we locate 1. Then this is 3i, so we go 1, 2, 3. So our complex number would be located right there. Alright? So 1 plus j3 is here. And you put a dot to represent this. Now, this type of diagram is called an Argand diagram. It's named after a Swiss mathematician named Robert Jean Argand, or Jean Robert Argand. So, this kind of diagram is called an Argand diagram. Let me write down the name below here. It is a Argand, A-R-G-A-N-D diagram. Alright? He said that he either popularized the use of this diagram, or Henri is the first one to use this diagram. Alright? So, it's called an Argand diagram. What about the complex number 2 minus 4i? How do you represent that? What do you think should be the case? What you can do, pause the video and use a piece of plain paper or graph paper to draw that, to represent that complex number. Okay, you've done it. Let's see. Here, we start at 0. We go to 2. Minus, we're going down. How many places? Minus 4. So our 2 minus 4i would be located right there. Alright? So, this is our 2 minus 4i. This was 1 plus 3i. What about, say, we have negative 3 minus 5i. Where would that be located? We'll go from origin to negative 3 minus, we're going down, so we go to the left, or negative 3, or minus, we go down, and it's negative 5 places. So here, that is where we end up. Alright, So this is negative 3 minus 5i. And what about 4 minus 6i? 4 minus 6i, where would that take us? Well, so negative 4 minus 6i. We want negative 4 minus 6i. We go negative 4, that's to the left. Negative 4 on the real axis. And you know what? Let's use negative 4 plus 6i. Negative 4 plus 6i. I want it within this region here. Alright? So, here. We go negative 4. Alright. 6 positive, so we go upwards. And 6 would be located here. I didn't have 6 there before. So let's write it. 6. And this is our complex number. Negative 4 plus 6i. So, represent those 4 complex numbers on this number line. So, we use the Argand diagram to represent them. Now, look at the situation. We have 4 different number lines here. Now, we can use one letter to represent each. Right? You can say, since they are names, uppercase, this is A, B, C, and D. But the usual practice is to use Z or Z to represent these. Now, you remember that the letter Z, I'll just call it Z instead of Z, is used to represent integers, but it's commonly also used to represent complex numbers. So we could say Z1 is equal to 1 plus 3i. Z2 is equal to 2 minus 4i. Z3 is equal to negative 3 minus 5i. Z4 is equal to negative 4 plus 6i. So if we have more than one complex numbers and want to represent them, right, we can name them Z1, Z2, Z3, Z4, and so on, if we have more than 4 complex numbers. Alright? So what we can say here is that Z is equal to A plus IB. Sometimes I put a little line across my Z, not to confuse them with 2, because when I'm doing a lot of writing, my Z, some of my Z start to kind of look like 2. So Z equal A plus IB. On the Argand diagram, the real part, which is A, is shown on a horizontal axis. Then we use a vertical axis to represent the imaginary part, which is IB.